And let us continue the clonable interface and object cloning, which is the subsection 1.c of the chapter interfaces, lambda expressions, and inner classes. Let us begin and recall what happens when you make a copy of a variable holding an object reference. So this is a variable original, and it will hold the object reference of a new created object employee with the name John Public and the salary 50,000. So this is original and this is the employee object with the name, the salary, and the hire day. And we have original is an object variable which refers to the employee object. Let me point here the hire day, which is in this example of type date, explicitly in order to explain the clone method for you. So here is our class employee. Now we changed it a little bit. We have a name, we have a salary, a hire day, which is not of type local date, what we have seen in the previous examples. It is of type date. What is the difference? The difference is that date is a mutable type, not like local date and string, which are immutable. So we are taking one immutable, one primitive, and one mutable type, and we will show our lesson on these three instance fields. So let us continue with the object variable copying, and let us set the hire day. So this is a mutable type. We can set something on this value. So we change the state of this object and we put the value 112000 inside the hire day. And then we will continue. There is no copy until here. It is only a creation of an object and changing the state of this object. Now we have the copy. Employee copy equal original. So what happens when I copy a variable? I have a copy, another variable named copy, and it will receive the same thing written inside original. I recall what happens in this case. We copy and paste the value inside original, which is the reference. So copy and original refer to the same object in the memory now. You should know this because we are used to drawing the memory state, whether it is in C, in Java, in Python, it is the same thing. So original and copy reference the same object. And if you, for example, raise the salary of the copy by 10%, if you invoke the method raise_salary and pass the parameter 10, the salary that was 50,000 will become 55,000, and this is for the same object because there is only one object of type employee in the memory referenced to by the original variable and the copy variable. So this is sad enough because you thought you have raised only the salary of the copy. However, the fact is you have raised both salaries. And also, if you set the hire day of the copy.set hire day 2002 December 31, what happens is that through copy you will access hire day, and then you will change the state of the hire day, which will become 31/12/2002, but this is the same value for the hire day referenced by the original inside the employee object. So this was a recall, and now you are convinced that we should use the object cloning whenever we want to use a copy of the object and not a reference to the same object. So we will recorrect our procedure. We will try to correct it. We will declare the original as usual and set the hire day as usual. And now we will correct. We will say employee copy equal original.clone. So normally copy variable will reference now to the clone of the employee, which is a copy paste of not this value here, but the copy paste of the referenced value. So we clone in the memory another space to hold an object of type employee, and then we copy paste all the instance fields. And the instance fields are 550,000 and the addresses of the string object and the date object, which are the same. So they are also shared now. And copy refers to the cloned object. If we make now copy.trace salary, what will happen? Let us watch on the schema what will happen. We will go to copy and then dereference, and we will raise this salary, which will become 55,000, and which is okay because the original employee didn't change his salary now. But as you can see, the red arrow points to something to alert. However, if you set the higher day for the copy, what will happen? You go to copy, you go to higher day, and then you set the higher day to another date, for example, 31 December 2002, which will change the state of this object reference to by higher date instance field, which is inside the copy employee. However, this was shared with the higher day instance field inside the original employee. So we didn't really solve the problem, we only pushed the problem one layer further. Okay, I need you to understand this. So this is why clone is a protected method of object, because object class cannot guess what would be the shape of your class, cannot guess whether there are references instance fields in your class or primitive instance fields. If it was sure that all your instance fields will be primitive, clone would not be protected. But this is the reason it is protected. They thought of you in order for you not to be fooled. So your code cannot simply call the clone method. Only employee class can clone employee objects. The reason is obvious, because employee class knows if it is safe to clone employee's object. It can make only a field by field copy. So we state here that the default cloning operation is shallow. You see, this is shallow. You cloned only the first layer, but the other layers, if there are shared objects between the cloned and the original copy, they are not cloned. So this is shallow cloning, and this is due to the presence of any mutable subobjects inside the object. So this is the clone issue, and for this clone issue you must consider for each class you need to decide whether one of the three choices. You decide whether the clone should not be attempted. You leave it as default, it is not attempted, it is protected. So you leave it as is. Or the default clone is good enough. You are fine with the shallow clone. All your instance fields are either immutable or primitive, and this is fine for you with the shallow clone. Or the default clone can be patched up by calling clone on the mutable sub-object. You need to correct a little bit your clone in order to make a deep clone. For the 2 and 3, we said for the first choice, you don't do anything. For the second and third choice, in case you choose one of those, to choose either the second or the third option, a class must first implement the cloneable interface and second, redefine the clone method with the public access modifier. Okay, you have to raise the visibility of your clone method, not only redefine clone method at override the clone method of object, you have to make it public instead of protected. Why? Because by default a subclass can call a protected clone method only to clone its own object. You will tell me how. Protected. Protected means you can access this feature from within the package and from the subclasses. So a subclass can call the protected clone method. Yes, it can call it, but only on her objects and not on the objects of her superclass. You don't believe me? Let's check. So I have prepared this program for you where you have your employee and your manager class, which extends employee. And as you can see inside employee, there is no clone object. Okay, there is no clone object here, and so there is no clone method, sorry, here, and so we have inherited the protected clone method of the object superclass. Okay, this is fine. Let's go to the manager class and let's write whatever function we want and which takes whatever parameter, but in particular we want to take a parameter of type employee and a parameter of type manager. And just to check whether we can invoke or not the clone method over the manager and employee. And as you can see, if I write var m2 equal m.clone, the compiler is very fine with this method. Clone is accessed and is accessible. But if I write var e2 equal e.clone, the compiler will complain and will start to put me red marks, and he will tell me that the method clone from the type object is not visible. Yes, it is not visible for you because we are inside manager. The method clone is visible for objects of type manager, but not for objects of type employee inside manager. So this is what I was saying. This is why you should implement clonable and redefine the clone method with the public access modifier. So the clone issue is here. Let us see what is the clonable interface. The clonable interface is one of a handful of tagging or marker interfaces. So this is a tagging interface. You put a tag on a class. Usually the purpose of an interface such as comparable is to ensure that a class implements a particular method or set of methods. So usually the interface declares some methods abstract, and if you declare your class to implement this interface, you must supply a definition of this set of methods. But a tagging interface has no methods. It has nothing. Okay? Its purpose is only to allow the instance of that to allow the question, is this object an instance of a class that implements clonable? Regardless that clonable does not have any method, but only this is a tagging interface. Okay, so why is this? Because we want to know if you chose the second or the third option or not. If you choose them, you must yourself implement clonable in order to tag yourself that I chose the second or the third option. If you didn't implement clonable, this means you didn't raise the visibility of the clone method to public and it's still accessible in your class. Okay, so this is the tagging interface, and of course do not use tagging interfaces in your own programs. Instead of this, use normal interfaces which will do a better job. But here I repeat again, the clone method is a method for the object class. It is already here, that's why we used a tagging interface. So let's see the option 2. If you choose option 2, this means you are very fine with the shallow copy. So all what you have to do is to implement clonable and to raise the visibility of the clone method. So you declare it public employee clone, and then you return the super.clone simply, and of course the clone method will sometimes it throws CloneNotSupportedException in case of a class that does not implement clonable. We know that you implement clonable, but the compiler doesn't know. We are obliged to declare this checked exception. So you have to declare in your class method clone throws clone not supported exception, even though you don't throw this exception. So this is the shallow copy, and this is the schema for the shallow copy. You have the sys object, which will refer to a certain object of type employee, and you clone it for the first layer only, and this is the shallow clone. However, the deep clone is the third choice. Also, you implement clonable. Also, you raise the clone public to public from protected to public, and you begin by cloning your object. Okay, so let's watch this animation. Cloned equal employee dot super clone. So we will begin exactly by the same schema we drawed in the previous slide. However, we have something to write here before returning clone, which is to correct this dashed arrow, which shares something, which still share something with the original object. So here we will change this share, and as you can guess, we will make the higher day refer to a cloned copy of this object of type date. So we will write cloned dot higher day, cloned dot higher day will refer now to higher day, so to this dot higher day dot clone. So we will create a clone, and we will make this object variable here refer to this cloned object, and this way you have only shared the immutable object. So the string object is still shared, but this is not a problem since strings are immutable. There is no method that can change the state of the string. You can change the name of this and or the name of cloned, but it will be referring, the result of changing the name will be to refer another object in the memory, and this object will still be the same. So the other copy will still refer to an unchanged value. So here is the animation, and this is called the deep copy. As for the clone not supported exception, we already said that you have to declare it unless this is your final class, and in which you are sure that neither you nor the superclasses have raised the exception. So you can put the call to clone inside a try catch block, and instead of declaring that you throw a clone not supported exception, you catch the clone not supported exception, because you know this will never happen. Otherwise, it is a good idea to leave the throws specifier in its place. Here comes the problems. Cloning of subclasses. Always with subclasses, when inheritance come into play, it brings with her the problems. Be careful, once you define clone for employee class, anyone can use it to clone manager objects. Oh yes. And what if manager objects contain immutable or mutable objects? What if manager objects contain, in addition to the employee instance field, a new instance field that is mutable? We will begin to worry. Will the method clone become shallow? Yes, it will become shallow. If the manager object happen to add only primitive fields or immutable fields, it will stay a good clone, but else it will become a shallow clone. So you have to worry, you have to redefine it. So see why initially it is protected, because of all these reasons. So the question in your class, when you define the class employee, you should ask yourself, should you implement clone in your own classes? Because if you implement clone, all of your subclasses will inherit this public clone. Okay? Are you sure you need it? Because if you don't need it, don't do it. If it is necessary, then maybe you should consider the alternatives of clone. Maybe clone is not the best solution. Maybe there you consider the copy constructor, the factory method, the object serialization. There are other alternatives you can consider and you can study, but these are advanced alternatives. But you have to think you have to think and consider. And you need to know lastly that less than 5% of classes in the standard library implement clone exactly for the same reason we are explaining in this slide. So let us first check the Java doc of the clonable interface and of the object class. Why? Because clone is inside the object class. And then we will see the listing clone of the textbook core Java. Let us go to the API, to the Java doc, and see the clonable interface. This is the clonable interface. A class implements the clonable interface to indicate the object.clone method that is legal for that method to make a field by field for field copy, for instance, of that class. Invoking object clone method on an instance that does not implement the clonable interface results in the exception CloneNotSupportedException being thrown. By convention, classes that implement this interface should override the object.clone, which is protected with a public method. See object.clone for details of overriding this method. Okay, we will see. Let's click here. Click. Okay, this is the contract of object.clone, and of course we are inside the object method. Let's go back. This is the contract of object.clone, and as you can remember, in the previous sections, in the subsection 1.a, we have explained the contract of compare to. Previously we have explained the contract of equals, the contract of hash code. So every method, and especially the object methods, they have contracts. You cannot implement them freely as you like. So this is the contract, and they say creates and return a copy of this object. The precise meaning of copy may depend on the class of the object. The general intent is that for any object X, the expression x.clone is different than X. You must be different. And x.clone.get class must be the same. And remember, this is reflection, so this is the actual class, not the declared class. And x.clone.equals x returns true, so the clone and the original must compare equal, and etc. etc. You read all the contract. We said that after the Java doc we have to see the listing clone. Let's go and see the listing clone. This is the employee class we showed you before, and we implemented here the exact clone that we explained just now. This is a deep clone because we cloned all the mutable fields, which are only one. And here is the clone test, in which we create the original variable and the copy, and we changed the salary, and we changed the hire day of the copied variable, and then we wanted to print the original and the copy. So let's run this, and you can see the original salary didn't change, the original hire date didn't change. However, the copy salary changed and the hire date changed. So this is the good copy, this is the good clone, and this is the listing. Before we end this subsection, you need to know that arrays also have a clone method that is public and not protected. It is ready to use. Use it to make a new array that contains the copies of all elements. Example, lucky numbers are an array of integers which contains 2, 3, 5, 7, 11, 13. You can clone this lucky number by invoking the clone method directly on lucky numbers. Int array cloned equal lucky numbers dot clone, and then if you change the last element of cloned, which is 12, this will not affect any of the elements of the lucky numbers because this is another array in the memory. So this was about this subsection, and here we finish all the section interfaces with its three parts, and next we will see together the lambda expression and then the inner classes. So until then, stay safe and see you.